So normal force and gravitational force in the y direction, you have friction to the left, and tension to the right. So when you do the sum of your forces in the x direction, it's just Ft minus frictional force equal to mass times acceleration. Okay, so tension is 50. And then frictional force, we have to remember that frictional force is equal to your coefficient of friction times your normal force. In this case, they're equal to
mass?
each other. No, it's normal force.
Okay, yeah, that's where I went. That's where
Okay.
I went. So it's mu times Fn.
Yeah. And Fg is mg. And in this case, because it's not accelerating up or down, these two need to be equal to each other. So then, and the mass was 10. 10. And then it says
Times
to use
10.
10.
So it would be 100.
Yeah. Okay, so that means my normal force is 100. So then this is 100. And then the coefficient of friction is 0.2.
Well, the one problem that I know.
So 0.2. 20.
That's what I got. What's it called?
Oh, I did that wrong.
Okay. So then the frictional force is 20. And that'll be equal to the mass of the thing, which is 10. And we're going to solve for acceleration. So that means 50 minus 20 is 30.
I mean, I guess if you're trying, that's so weird.
I did everything else, and then I was like,
Then you get 3 meters per second squared.
whole problem. Procedure problem.
Mm-hmm.
There's the one thing I said.
Good, bad?
The one thing I said.
Yeah.
Because I knew they would have like.
Okay. So, on the diagrams below, draw and label all the forces acting on each block in case 2. So that's when they're getting pulled. So this one has the tension to the right, this one has tension up. And these have to be equal to each other because they're the same string.
Yeah.
And then we have frictional force acting on these. So
Wait, but wouldn't they be like
on
two
this-
separate?
Yeah, I have them as 2 separate.
Oh, right.
Yeah. Okay, so then I have frictional force that kind of pushes back on it. We have gravitational force pulling down. We have normal force pushing up. And then this one will have gravitational force going down. Okay. And let's see, this normal force needs to be the same as that gravitational force because it's not accelerating up and down. And this tension is going to be bigger than that gravitational force. Or sorry, no, gravitational force is going to be bigger than my tension. So those are not the same because it needs to accelerate.
And like to make them equal, we just write dashes like that, like
Yep.
in the actual test. Okay.
Yep. Yeah, just like that.
Well, we're supposed to know that.
Okay,
That's an exception.
that's it for part B.
B.
Okay. Part C, it says to calculate the acceleration of the 10 kilogram block.
Carbon would share 2 extra.
Okay, so I'm gonna do it on this part just so that way we can look at the force diagram at the same time. So the sum of the forces in the x direction. Do you guys want me to do it as one big system or 2 separate systems?
2 separate?
Yeah.
Sure. Okay. So I'm gonna call block with the 10 kilogram block 10. So that one we have tension minus the frictional force acting on block 10. And that'll be equal to the mass of the 10 times acceleration. And the acceleration for both has to be the same because your string's not getting any longer or shorter, so they have to experience the same acceleration.
Wait, is that one for this block?
Yeah. So I'm going to do 10 for the 10 kilogram block, and I'll do 5 for the 5 kilogram block. All right. And so T minus, oh, we figured out the frictional force on the 10 before. That was 100.
Yes.
Oh, no, it was
20.
20. Okay, so I'm just going to put in 20. Mass is 10 times acceleration. And we don't know that yet. So we have two unknowns. Then I'm going to do the y direction of block 5. Okay, so I use to the right is positive for this one. So if I say that direct to the right is positive for the 10 kilogram block, then that means that down is going to have to be positive for this one. Yes.
I think that's
So it'll be plus FG minus FT equals MA. Because otherwise, the acceleration for this one, for the second one, is going to be opposite the other one. So if they both had the same acceleration, one would be going up and the other one would be going to the right, and they'd be going towards each other, which makes no sense. So we have to make sure that to have these accelerations the same, that we need to switch which way it is. All right, so this is FG of the 5 kilogram thing. This is the mass of the 5 kilograms. So this is mass of the 5 times G minus FT equals 5A. So this is 5 times 10, right? Because G is 10 in this
Wait,
one.
I got lost after that part. The blue.
Here.
Yeah, like once
Okay.
you started out.
So when I was doing this, I said I need to make downwards positive. Because when the other block moves to the right, this block is going to go down.
So it would be
So-
FG minus FT.
Yes, exactly. So then FG is just the mass of the 5 times G.
But instead of like catching fire like the brake fluid in the pool does,
So that would be 100.
super fast.
50? 5 times 10 is 50.
Wait, wouldn't it be that mass?
No, because now I'm doing this thing.
Oh.
This one was for the 10 kilogram thing. This is for the 5. So this is for the 5 kilogram thing. This is for the 10 kilogram thing.
But are we only working with the 10 kilogram? 'Cause-
We did for this net force equation. And now we're doing the 5 kilogram one in the y direction. Here. So do the sum of the forces
We just name drop like.
in the y direction for the 5 kilogram thing. Yeah. And put a little 5 after this, so you know that, yeah, there you go. So then this is FG of the 5, so put a little 5 there. This is mass of the 5, put a little 5 there. Because that way you, I don't want you to think that these two are the same. Yeah. Okay, so now we have 2 equations and 2 unknowns. So this is one equation. So this equation and this equation. So we have 2 equations and 2 unknowns. They have the same tension and the same acceleration. So I just need to make a systems of equations. Okay, so I could solve for FT in one of these and plug it into the other one, or I could solve for acceleration in one and plug it into the other. I think that it's easiest to solve for tension.
Yeah.
Because then I don't have to do division. But you can do whatever you want. Do you have a preference of which one I solve for FT in?
That one, because wouldn't you just have like 20?
This one? So I'm going to start with this one. And so FT will be equal to 10A plus 20. And then I'm going to take the other equation. And I'm going to take this for FT and plug it in for FT.
From there would it be 50 minus 20 minus 10A?
50 minus 10A
An equilibrium
plus
gas
20
of hydrogen and oxygen, and you light that, it'll
equals 5A. Is that what you said?
obviously just go like,
Yeah.
boom.
Okay.
So fast.
And so then I'm gonna end up with 50, and then this is where you have to be careful, is this minus needs to distribute in. So it's
Yeah, I thought
minus
distribute that
10A minus
Well, he knows that
20
it's highly explosive.
equals 5A.
He knows that I just wanna pop them.
So then
Actually, I
50
did do it
minus
right.
20 is 30. And I can add 10A to both sides.
A machine with it.
And so that'll be equal to 15A. Divide both sides by 15.
To get A equals 2.
Yeah.
I did do it.
Yay! Yep, 2 meters per second squared.
Okay, great.
Yay! Uh-huh.
Thank you.
Yeah.
When do we turn this in?
Yeah, but I want you to keep it for now, Tom.